Okay, so tell me if you know about condensation and evaporation while I take some attendance for all of our swept people. Okay, take a second. It's just a yes or no answer. Yes or no. It's not hard. Just want to see where you guys are at.
And he locked it before it even started. Yeah.
Oh, you guys what?
Yeah. I was there before the roommate.
Joe, can you open that door for me?
Where's Miss Anderson at? She's not there, she probably need to get swept, but the uniform.
Nah, yeah, so get that filled out. I need that ASAP. ASAP. You'll find a spot. I'll squat. Trying to put a guy. No, at the end Okay, so we are on to a new topic. Okay, so if you guys were absent yesterday, okay, we took our quiz. If you guys weren't here, okay, you guys gotta sign up for advisory. Okay, so I can crack that open. We did that online. Okay, so if you weren't here, I'm not gonna ask you. Okay, just make sure you guys sign up at least for tomorrow, because that is gonna be the time that closes. But now, since we're on the new topics, okay, we've talked about carbon cycle, we've talked about nitrogen cycle, okay? Now David gets to jump in where we're at, okay? So, now I just want to know, okay, do you know, yes or no, what condensation is? Hands up if you guys know what condensation is. Nice and high. Condensation. David, since you're a new guy, I'm gonna ask you, what's the best way you can describe condensation if you could try and describe it?
Let's say you have like a glass bottle with ice in it, and the outside's gonna have like a kind of watery, wet, feeling like that. That's what it is.
That's condensation? Yep, okay. So, yeah, so exactly, okay, so if I had like my bottle here, okay, if I had this filled up with like ice water, stuff like that, okay, and I just let it sit there, at some point I'm gonna start to feel the water coming out of this bottle. And you're gonna be like, how is that even possible, okay? It's condensation, okay? It's the water is getting cold on the outside, okay? Let me see another version. Does anybody else have a better way or another way they describe condensation? Do you think we're good with that? I think David knocked it out the park. Good, okay? Evaporation, okay? How many of you guys know what evaporation is? Hands up nice and high. Okay? Carlos, what's your best description of evaporation? Say again? Something that's disappearing? It'll like disappear like right off the table. Anything, can you be specific on like what that something is, Trinity?
When water is drying up.
Exactly, so water is drying up and then it disappears, okay? Anything liquids, anything like that, okay, that's exactly how that goes, okay? So condensation, okay, we're talking about water vapor, okay? If you really want to be specific about definitions, okay, that's what we'll look at right now. Okay, but condensation is just the condensing, okay? We're mashing up a bunch of water molecules, okay? And we're turning them into a liquid. Okay, evaporation is now turning that liquid into a gas again, okay? It's getting heated up, okay? Everything is splitting apart, okay? And that's what we get, okay? So, get your notes or get your laptops clicked in, okay? You guys have your doodle notes. That doodle note assignment that I had posted for you guys, that's what you guys are gonna be looking at. I think that had our original ones on there. The water cycle, carbon, nitrogen, okay? So it's all on the same link. Let's get that pulled up so we can follow along together. Okay, so we've already looked at the carbon cycle version of this. You guys designed your own nitrogen side of this. Okay, now we're gonna go jump back into the water side. Okay, so that's what we're looking at today. Okay, so if you clicked into that, okay, I think it's slide, where is it? Slide 7. I'm over here moving too fast now. Okay, slide 7 is gonna get you to the water cycle. There we go. Okay, so get to that.
There's nothing on the bottom.
Oh, that's because you were, I had to add you separately. Let me send this off to Dave real quick, hold on. Alright, there you go, Dave. Yep, send. Why did it send?
I've been turning everything also why?
Huh. It's not even letting me message you. I don't think I have permissions yet. Okay, well, that's why I got it up here. Let's just follow along up here. If you need to move up, if you can't see that, that's perfectly fine too. Okay, so first things first. Okay, we've looked at carbon. Okay, we've looked at nitrogen. Okay, think of it this way. I made the joke a couple times now, the comparison. Okay, so carbon is like the what's giving us life. Okay, that's like giving us our living, breathing energy. Okay, the nitrogen side of things. Okay, they help fuel the fire. Okay, they give us the fuel that we need basically to grow big and strong. Okay, for plants, if we're talking plant-wise. Okay, we're talking about the chlorophyll. You guys have brought that up. Amino acids. Okay, all those different types of things that build us up. Okay, carbon gives us that starting spot. Okay, what's in the middle of it all? Okay, is the water cycle. Okay, so for these first two setups, okay, carbon and nitrogen, we've seen how it's basically moving throughout this entire cycle. Okay, we've seen it up in the mountains, we've seen it up in the water, we've seen it up in the trees. Okay, it does not matter. Okay, it's all been the same thing. Okay, but now we have the broad spectrum version of it, which is water cycle. Okay, so first things first, over here on the left-hand side, okay, we start off with evaporation. Okay, a good chunk, good portion of the earth, okay, and you as a human being, okay, are made up of water. Okay, so it's very big, very big. Okay, water takes up pretty much like 60–70% of the earth. Okay, so with that being said, okay, with the water cycle here, okay, we have evaporation. Okay, you guys just told me, okay, that's basically heating up water, heating up a liquid. Okay, and that liquid is now dissipating. Okay, it's disappearing, turning from a liquid to a gas back into the sky. Okay, once we get that happening, okay, we got condensation. Okay, that's the first thing I asked you right now. Okay, condensation. We also just answered, okay, that's just condensing water molecules so that we can get some water up into the sky. Okay, that's all that's making is clouds. Second part of that, okay, is we got transpiration and transportation. Okay, you guys all know what transportation is. Okay, you guys all got in it to get here. Okay, whether that was a bus, whether that was your feet, okay, your Lamborghinis on your shoes, okay, or maybe you hopped in mom's car, your brother's or sister's car. Okay, transportation. Okay, it's just moving something. Okay, over there on that word wall over there, okay, I added our prefix. You guys all have the prefix in your notes already. Okay, that trans is just telling you that something is moving across or beyond. Okay, so if we're looking at transportation, okay, that's just the movement of clouds. Okay, the movement of water. Okay, that's what we're looking at with that. Okay, if you guys are athletes in here, okay, any athlete might have heard a coach or maybe somebody say transpire. Okay, you're transpiring. Okay, it's a very big word for sweating. That's all that's saying, okay? Us being made up of water, okay, the way that our bodies cool itself down as humans, okay, just living, breathing organisms, okay, we use water as a heat or like a cooling factor, okay? So when you start sweating, okay, what's transpiring, okay, is you're letting that water out of your skin, okay, so it can evaporate and cool you down, okay? It makes you cooler, okay? And then when you guys are hot, or when you guys are cold, okay, your body gets all ashy and dried out, okay, because it's trying to hold on to all that water, okay? The longer it can hold on to that water, the more retention it can have with the heat, okay? So transpiration, okay, is basically the plant's version of releasing, okay? They're sweating, okay? This is just a plant that is sweating, okay? Got a cross-country runner in here, and I think the girlfriend of the cross-country runner and some other runners in here, okay? And we're up at the crack of dawn, okay? If you guys go outside, it's cold. We all know that, okay? But then you guys go into the grass. You step into the grass, and it's cold as heck, is it not, Amy? It's cold, okay? What that is the plants transpiring, okay? And they're letting off more water out into the atmosphere, out into the air. So if you've gone out into like your backyard in the morning time, it's probably a little bit colder than the front yard, okay, because of the vegetation and the plants that are back there. That's just transpiration, okay? It's just more water out in the air, okay? When we're looking at the second half of this, or the third half of this, third, okay? Now we're looking at precipitation, okay? This is rain. It's another word for rain. That's the big science word for rain, okay? And specifically, okay, in our picture here, we have it raining in the mountains, okay? You guys being carbon molecules and nitrogen molecules, okay, when our games, okay, there was a time when you guys were a carbon molecule in the atmosphere, and then all of a sudden you dropped down because it rained, okay, and then you were on the floor, and then somehow, some way you ended up in the ocean. And you're like, how does that happen, okay? Well, how that happens is surface runoff, okay? It could rain all day long up in the mountains, okay? It can rain, okay? Just like up in Flagstaff. It can rain up in Flagstaff all day long, okay? But then we have what we call New River. Everybody, you've all driven past New River, driven over it at some point and somehow, okay? It's the canal that we all drive past, okay? That water has to go someplace, okay? That's what we call runoff. Okay, so it is now just dripping, okay, gravity's doing its thing, okay, it's pulling that water down the mountain, the hill, the valley, wherever the heck it may be, okay? That water is now running off, okay, that's the word that we use, that's what they created, okay, it's runoff, okay, it's running off the land, back into the ocean, okay? And if it doesn't sit anywhere, or if it doesn't run off anywhere, okay, then we have what we call percolation, okay? Not that percolation. Yeah, okay, percolation, okay? All that's saying is water has nowhere to go, so it's sitting there and it's getting absorbed into the ground, okay? It's absorbed into the ground, okay, we call that soil saturation, okay? It's a saturated soil, wet dirt, okay? And then once we get there, okay, water somehow finds its way back to water, okay, in a weird, magnetic, chemistry-oriented way that we've talked about, okay, with that attraction that we've talked about, okay, between atoms. Okay, if it does not go back to the water setup, it ends up in what we call an aquifer, an aquifer. Okay, that's basically just an underground reservoir of water. Okay, it's where water gets to stay underground. So when we're drilling for oil, when we're drilling for all that different types of stuff, okay, we gotta bust past the aquifers of the earth. Okay, we gotta go through the water. Okay, we gotta go through these crusts. Okay, we gotta go through all the layers just to get to the oil. Okay, fossil fuel is way down below the aquifers. Okay, that's what makes them oil. Okay, it's that wetness. Okay, that's that. Okay, but specifically like this, okay? How is water used by the organisms? Okay, this is something I would ask you guys on a test, most likely probably tomorrow morning, okay, for bell work, okay, just to see if you guys are paying attention, okay? So like I said, how is it used by organisms? Okay, it's a solvent, okay? We use it for heat, okay? We use it for the cold, the heat, okay? The root word of solvent, solve, okay, is to solve a problem, okay? In our bodies, 90% of the time, there is something going on. Problem, whether we think it's a problem or not, Okay, our body is still trying to regulate, it's trying to make itself normal. Okay, so we use a solvent, which is our water, okay, so that we can buff our temperature. Okay, it's the buffer between us hot, it's the buffer between us cold, okay, it's the buffer that keeps us what we are. Okay, you walk in, it's cold, it's mucho frio, okay, that's why. Okay, so solvent, solve. Okay, evaporation, okay, we just answered that from Bellward, okay, now here's the hard definition, okay. All it is water that's being heated up, okay, turned back into a gas. Back in biology, you guys should have learned at least the first or 2 stages of matter, okay, that's why we started off sophomore year this year with matter as our vocab word, okay. So matter is either a liquid, it's either a solid, or it's a gas, okay. I could take some, what's the best way I can think of this? I could take some water, yeah, just use water, okay? We take water, I could freeze it, get some ice cubes, that's a solid, okay? If I let it melt, turn it into a liquid, if I let it sit there long enough, it'll evaporate back into a gas. Now we can breathe. Hydrogen, oxygen, all that stuff gets evaporated, okay? Transpiration, okay, water can evaporate from the leaves of the plants. Okay, if your tiny holes called stomata. Okay, if you guys are anatomy people, if you guys get that far, okay, maybe on our trip, okay, when we start talking some anatomy stuff on our field trip on Monday, okay, transpiration, okay, plants have these things called stomata, which is the human version of a pore. Okay, where you guys get all your pimples and all that nasty stuff, eating Takis all day long, okay? Yeah, that's your pores, okay, but for a plant, okay, it's a stomata. Then you got good old condensation. Okay, which again, you guys have already answered, you were spot on. Okay, so it's water vapor that condenses. Okay, it's a gas, that's the vapor. It's just condensing down. Okay, and it's forming a solid, something that we can touch, we can see, we can feel it. Okay, it's a liquid. Okay, now we get clouds in the sky. Okay, we get all these different types of things. Okay, as it starts to cool down. Okay, so that's that, condensation. Easy money. Precipitation, okay, you guys all know this. Okay, it's just rain. It's just rain coming from the sky, anything falling from the sky. Okay, not like Chicken Little with the sky falling out of the sky. Okay, precipitation is rain, snow, hail, sleet, okay, which is basically just a combination of rain and snow all at the same time. Okay. Hands up if you guys have ever been in a hailstorm. It's scary as heck, ain't it, David? Crazy. I was at work one time when I used to work construction, and we were in a house. Okay, it had no walls, sucked. Okay, so there's no walls. It's just the frame of the house. And a hailstorm blew in. It was golf ball size hail. I was smacking us. I was hiding under a tarp and all types of stuff. Okay, so that stuff's not fun. Okay, hail is crazy, crazy. Okay, but then we got percolation. Last word. Okay, that's just water moving through the soil layers. Okay, it just finds its way weirdly back to the oceans, okay, back to the rivers, the lakes. Okay, if we go and if we start talking the chemistry side of why that is, okay, there's a magnetic pull and attraction that we can all see. Opposites attract, okay? There's an attraction that we can see as to why that happens, but we could learn that in another chemistry lesson, okay? But aside from that, okay, if it doesn't percolate down into the earth, okay, we get runoff. Okay, those are the only 2 ways that works. Otherwise, we end up in an aquifer for the rest of our life until we get sucked up. Okay. So that's your doodle notes real quick for your for the water cycle. Okay, I want you guys to pull back up to this first page and put some color on that thing. Okay. That's gonna add you guys to the second part of your coloring. Okay, that's gonna get you guys the second part of your points. Okay, and then it tells you guys obviously what you guys are looking at. Okay, when you guys did these doodle notes the last time, okay, you guys filled out everything, okay, and then I gave you guys an open note test, okay, and you guys didn't even know where to look, okay, because things just weren't color coded, things just weren't highlighted the way you wanted them to be, okay. So find some color, okay, make it match up, okay, do yourself a favor, okay, spend the next 10 to 15 minutes just getting that colored in. Okay, and when you guys are done, turn that in. And then when you're done with that, okay, get your laptops back out, okay, if you haven't closed them up already, okay, so you guys can finish up on your cycle creation. Okay, I want you guys to get that submitted as soon as possible so we can move on from that. Okay? So that's what you guys got. Spend the next 10 or 15 minutes grabbing some color, grab some markers, get creative with it, and be around to see who's doing what. Be easy money.
Easy.
You get that filled on me?
Yeah.
Brown slip. Ruby, you just gave me yours, right?
Yeah.
That is it. Wow. There's this air pollution kit I want us to go outside and get. We test the air outside. Freaking other science teacher took it.
Mister, you're always letting them take everything.
I ain't letting them take it. They deleted my message and gave it to somebody else. That is disrespectful.
They deleted your message.
Yeah, look at that. They deleted it and gave it to the other teacher. And I'm the one that wants to have fun. Jeez. Baby, get that light on. That's it.
I get the book. The one that you're reading. Is it dark?
Good? As you guys are doing that too, okay, I know you guys probably didn't put this in there. Okay, drop your ocean in here, even though you probably know it's an ocean. Okay, put your ocean in there. Put your little lake in there. Sounds stupid, okay, but just identify it. Identify it for yourself. Don't have to think farther. Put the little ocean, put the little lake. Get it wrapped up, and get back busy with what you know you need to do.